Hello, welcome back. In the previous video, we stopped on this exercise. Now, I gave you 10 minutes, but now let's do it together. So, I'm going to start off from a new box. This is in class exercise number 2. So what we were asked to do, so we prompt the user to enter an integer for a day of the week. Okay, so step 1. So we are going to input the day of the week from the user. So yes, day of the week equals we are going to input, so please input an integer for a day of the week. Here I'll go such as, such as 1 for Monday and 7 for Sunday. Okay. And then I'll convert this to an integer. All right. Step 2. Now the program checks whether the corresponding day is a weekday or a weekend. Let's see, check whether it's a weekday or a weekend. So here we are going to use the following. For instance, we'll first check if it's greater than 1 and less than 5, right? So we can write if day of the week is greater than or equal to 1. If so, then we put another if inside. Day of the week is less than or equal to 5. Then it's a weekday, right? Here I put else if day of the week is elif day of the week is greater than or less than 7. I print it's a weekend. And for else, I'll say invalid input. So this one, so if it's, for instance, 8, 9, 10, if the user enters something like this, I'll go, so since it's greater than 1, but not less than 7, it'll be an invalid input. But for those who enters, for instance, negative, so for instance 0, I'll put it over here. So this is also an invalid input. Okay. So I go, please input an integer for a day of the week, such as 1 for Monday and 7 for Sunday. Let's go 6. It is a weekend. Okay, one more time. Let's go 3. It is a weekday. Awesome. So let's try 8. Invalid input, right? Also -4. That's also an invalid input. Okay. So that's that. Next, we are going to talk about logical operators. So the previous example here, this is a bit nasty because we have several conditions we could have merged them, right? So if it is greater than 1, also if it is less than 5. So basically, if we have a way of saying I need the weekend between 1 and 5, it is in between. So it's greater than 1, greater than or equal to 1, and it is also less than or equal to 5. If I have a saying like that, then I could have used, I could have merged them, right? So here it is. We can actually use AND to combine the two. We can also use OR. For instance, you only need, maybe you only need one of the conditions to be true. In that case, you put an OR. If you need the opposite, if you want not equal to or like not greater to, you can also put not, okay? So these three we can play with. And the truth table for not is going to be like this. So if you write, for instance, not P, and when the P is true, it's going to be just the opposite of it. For instance, assume age is 24. 24 greater than 18. So this is actually true, but if you have not true, that will be false. Okay. Or if the condition, if the proposition is false, for instance, let's say that the weight is 140 pounds. 140 is equal to 150. No, it's actually false. But we have not false, which makes it true. So the truth table for AND, here we are working again with age 24 and weight 140. And we have the two propositions, okay, P1 and P2. So let this be P1 and let this be P2. So we have AND. What does it mean? It means that they both have to be true. This and this, these two propositions have to be true, such that the compound proposition is also true. If one of them is false, if either one or both of them is false, then the end result will be false. So this is the end result for the compound, P1 and P2, okay? So it's false under three conditions. If both of them are false, or if at least one of them are false. It doesn't really matter the other is true, that will end up false. Only when they are both true, then the ending proposition will be true. For instance, 24 greater than 18, so this is true. And 140 greater than or equal to 140, this is true. True and true, it is a true, okay? So it is logical, but you would have to see it on a truth table. And then we have OR. So it's actually logical. So you need either one of these conditions to be true. So you have the proposition 1, proposition 2, and then you need P1 or P2 to be true such that the compound, the two of them would be true, okay? So the compound is true if they're both true or just one is true. And it's only false when they're both false. So here 24 less than 18, this is false. 140 greater than or equal to 150, no, this is false. A false or a false makes it false. Otherwise, false or true is true, true or false is true, and true or true is obviously true, okay? So if you see an OR, just one true is sufficient. But if it's an AND, two true is sufficient, is necessary. Okay, so here just one true would do, but here both of them to be true is necessary. Okay, And then we have another in-class exercise. So I'll actually do it right here. So we are asked to write a program that prompts the user to enter a year as an integer and checks whether it's a leap year or not. So here, so a leap year is basically when February 29 is a day. So every 4 years basically, but it's actually not every 4 years, it's also every 100 years and every 400 years. So it's either, so the definition of it is it's either divisible by 400 or it is divisible by 4 but not divisible by 100. Okay, so if you want to do it yourself, just pause the video here and try to do it in the next 15 minutes, or you can just follow me. So I'll do it for you guys. Okay. Awesome. So we have in class exercise number 3. Yeah, step 1. So we first prompt the user to enter a year as an integer. So here, input the year as an integer. So we go year equals, I'll directly convert it to an integer. Please enter the year as an integer and press enter. Right, so please input. Okay, and then the second step, so we check whether it's a leap year. Check whether it is a leap year or not. So how do we check it? So we have the following. It is either this or the compound thing here. Okay. So what I'll write? I'll use parentheses. It is either this one or the other one. So it's either the first one or the other one. If so, then we print it's the leap year. Else, we go it's not a leap year. Okay, but what are these conditions? So the first one, divisible by 400. So how do we check divisibility by 400? We use the remainder. If the remainder is 0, that means it's divisible by 400. So this is condition 1, divisible by 400. For instance, if it is 800 or like 2000, right? It's like 20 years ago. So 0, right? So the remainder is 0. So this is how we know the divisibility by 400, by checking the remainder. If the remainder is 0, then it's divisible. It's called divisible, okay? All right, so we have the remainder by 400 is equal to 0. Or, okay, so here we have two propositions. So this one P1, okay? Now P2 and P3. So I go P2 and P3 inside this guy. So P2 and P3, okay? And what was P2? Divisible by 4, okay? So instead of P2, I go divisible by 4 again. If I divide it by 4 and the remainder is 0, then it means divisible by 4. that is P2, and P3 is not divisible by 100. We can actually do it in multiple ways. So we can, so instead of this, not divisible by 100, right? So it's not. So this is divisible by 100, and we have not. That means not divisible by 400. Okay, so another way of doing it is instead you can do not equal to. So exclamation mark equal to means not equal to. Okay, so there are a couple of ways to do it, but I'll just do not because we just learned not, and the point of the exercise is that we use not. Okay. Okay, so here. Okay, please enter the year as an integer and press enter. Let's say 2021. It's not a leap year. Or try 2024. It's a leap year. Okay. How about I go 1900? It's not a leap year. Oops. Well, I thought every 4 years it would be a leap year. Actually not. So let's do 2000. It is a leap year because it's divisible by 400. But if for instance, 1896, this is a leap year. So you assume 4 years after this would be a leap year as well, but 1900 is not a leap year. So they sort of have rules. You only get to see them every 100 years. But we sort of passed that 2000 because it was divisible by 400. So it's almost every 4 years except the hundreds, but not the 400. So it's like a weird rule, but that's how the world goes around the sun. So okay, so we read in the year, and then we check. Okay, so this one divisible. So this is P1 divisible by 400. P2 divisible by 4 and not divisible by 100. It is a leap year and it's not a leap year. Okay. All right, let's do a review and then we are going to call the day. So what does the following program print? Oh, okay. So if age is greater than, oops, so age is 19, so it's actually not, so this is false. So we go else if, so here we have not 19 greater than 18, not true. That makes it false. This is also false, right? So we again skip. So we don't print anything. Okay. So here we have, this one is false, right? False, or this one, 181 less than 190, that is true. A false or a true, we said just one is sufficient. So here it's true. So we are in there. So we don't really check this part because this has else if, right? But this was true, so it requires all the previous ifs to be false, but it's not the case here, so we skip that. So we only print the score, which is 75. Okay. Again, so we have true, so this one is true, right? 19 greater than 18. 181 less than 180. That's a false. 181 is not less than 180. True and false. So we need both of them to be true, but one is false, so it's false. If it is false, now we can go to the else part, else if. But again, here we have to check whether this is true. Okay, so 19 greater than 19. That's a false. Or this one's false. Or let's see, 181 greater than 190. That's also false, right? So false or false, that's actually the only time that it becomes false. So this is also false. So we again skip that part and it doesn't print anything. Okay. We have, okay, so this one is not age. So let me actually put not age greater than 19, not false. So a not false is actually true. And 181 less than 180, this is a false. True and false is actually false. So we go to else if part. Here again, we have not something, okay? So I go not age greater than 18, that's actually true, but not true is false. Or height 181 less than 190, that's true. So true or false or true is true. One is enough. So we go here. Score was 75, it becomes 85, and then we print 85. Okay. So the trick here is that now we have a parentheses. So if you see a parentheses like this, so this is a parentheses, yeah. So if you see parentheses, you have you do it first, okay? Okay, here it's actually exactly the same. So not false, that's actually true. And so this is false. So that makes it false. If it is false, we go here. Here we have not something, okay? So we first do the inside. Age greater than 18, true. Or here actually at this point you don't have to check the other one because you know that one is enough, but let's do it for the sake of it. Height less than 190, that's also true. So we first do the inside. True or true, that's a true, but we have a not, and not true here, it makes it false. Since this is also false, we are skipping that. So it doesn't print anything. Okay, so this is the final exercise, the review questions. Here we have not, so we have again two parentheses. So let's see, this one is not something. We first have to do what is inside. So age is greater than 19, that's a false, and height less than 181, that's also false. So you first do the inside parentheses. False and false, that's a false. But not false is actually true. Since it is true, we are inside the if block and we print score. We don't actually check this one because it's true. So this starts with an else with conditions on the first one to be false, but that's not the case. So we print 75, which is the score. Okay. Awesome. So this concludes this week's lectures. I'll give you 3 practice exercises, actually 2. So the first one, I'm going to ask you to write a program that prompts the user to enter a movie's IMDb rating and Metascore. So a rating between 0 to 10, that may include decimal like 3.5, but a Metascore is between 0 and 100, and that's an integer. So you input two, first the rating and the Metascore, so two inputs, and then you check whether the movie is recommended to watch. A recommendation is when the rating is strictly greater than 7.0 and the Metascore is strictly greater than 60. Okay. And the second exercise that I'm asking you to write a program that prompts the user to enter the day, month, and year that they're born, and display whether he or she can legally purchase beer in the United States. So here in this example, you ask, give me a beer, please. And then the guy says, can I see an ID? And in your ID, you're born the 6th of December 2000. Means that you're under 21. And that's when the bartender says, I'm sorry, but I cannot sell you a beer. So you're getting three inputs, month, day, and year. And then you're checking whether legally purchase a beer in the United States, that's the age 21. So you basically calculate from today's date. You sort of count the 21 years old, and then check whether the ID says 21 or above or below. Okay. All right. So I'll just finish the lecture as usual. I want to thank you. Oops. So I'll be going to the first slide, and then I would like to thank you for your participation. Okay. Take some time. But here we go. Thank you for your participation, and I hope to see you in the next class. Bye.